Hey, hey, hey. How's everybody doing? Welcome to a really weird episode. This is going to be a little bit different. I am not on my YouTube channel here doing music today, although you can hear my album playing in the background, hopefully, if I get this audio set up right. I've been having issues. Um, I wanted to put something out there on record because one, I don't have enough storage space to compile this into one video on my device, so I figured if I do it live it'll be stored in the cloudy area, and I can download it later onto my laptop where I have all kinds of room. um, so what I'm doing is I want to explain why I've been sidetracked from doing the music thing. um, I get really focused on a project sometimes, and I can't really do anything else until it's resolved, or until I've um, till my attention has been drawn elsewhere, and I get sidetracked and obsess over something else. Um, but this is a big one. This is one that I've been working on for a very, very long time, and I'm gonna. I don't know how loud that is for you. There. Um, Before I even get started, I'm gonna read a message I wrote for a friend who genuinely asked me, "Hey, tell me more about this. What is this about?" Okay. Um, so I'm just gonna read it, and this will be my intro to the video. So, scene, action, whatever. um, okay, for those not following, I gotta put this closer so I can look at you. For those not following along, I realize my posts are all over the place. Music, work, weather, short stories, and don't forget the rants. Uh, so if you look up free electric generators on YouTube, you will see a lot of fake BS with hidden wires and motors and whatnot. The real ones create generator coils from old microwave transformers, and run like a weed whacker motor or something to run it. And that uses gas, which is not free. So in the title it says free electricity, and they build this contraption and they put a gas motor on it, and it's not free. It's burning gas. So I've been toying with an idea since grade school. Okay, when I got a bad grade for an assignment, we were given to invent something. I know I'm a terrible reader. uh, my laser my laser pooper scooper was deemed unrealistic. Yet today they can clean metal with a laser and shit. So how unrealistic was it really? I mean, anyway, I obsessed over it. I had to create something everybody could use, something the world needs. So I started learning about electricity in my copy of The Way Things Work. Have you ever seen that book? Keep in mind, this was me in like fourth grade, okay? Like fourth grade. And but around high school, the thought was still there, and I designed a model. Theoretically, I never built one, where a tube made into a donut would have fan blades all around inside it. Two of the fans would run on electricity. The rest would spin generator motors. And my idea was that the two fans would circulate the air around inside the donut and spin the generator blades, and two of which would be dedicated to powering the two fans pushing all this air. And it's a neat idea, but how do you start the two fans initially? You know what I mean? Or you start it off a battery and have like a switch to switch over, or it just. And in high school, I had no experience or fabrication skills whatsoever, so like I couldn't have answered that question back then. You know what I mean? I went to trade school, PJCC, it's Penobscot Job Corps up in Bangor, Maine. And yes, I walked onto Stephen King's property and knocked on his door. I was trying to give away puppies. I actually went, you know how they have this gate? Everybody sees his gate. The gate was open, so I just walked right up to the door and freaking rang the doorbell and knocked on the door holding onto a puppy. They never answered the door, but as we were leaving, we noticed like the whole family or somebody was in the back in the driveway getting into vehicles and shit. So they must have been already packing up to leave or do something, and just that's why the gate was open, or so, I don't know. But that was me, by the way, Steven. I apologize. I was just being a stupid kid. I figured after Cujo, you'd like a dog. Don't ask. It was dumb. Anyway, so, but I went to that Job Corps to learn how to weld. I have since spent about 25 years busting my ass, learning everything I can, bouncing from one shop to another. I did pipe work. I did sheet metal. I've done automatic door work. I've worked on heavy equipment like excavators, excavator buckets, and made like the opposable thumbs and shit for them. Modified cherry pickers for it was Katrina. I think it was the Hurricane Katrina. We had cherry pickers come all the way up to Maine and have us take the cherry picker off the back of the truck, which is near the cabin, and take it off and put it at the back so they could pick and put in the bed of the truck on this side and have a trailer and put on the bed on that side and have 2 loads per trip. So we modified a couple of cherry pickers and shit for like the Katrina and whatever. Anyway, and just too many jobs and machines that I've worked with to list, but I absorb every bit of knowledge I could, paying particular attention to the old timers on the jobs, because I mean, you gotta admit, the work ethic of today's workforce is not what it used to be. Not nearly. You can. It's not. And there are a few of us that strive for that style mentality, or you know what I mean. And so I mean, that was me. I wanted to know how the good old boys did it, you know what I mean. I wanted to do shit right. I wanted to friggin' I wanted to benefit from their experience. I mean, I didn't want to wait 40, 50 years, 60 years to have their kind of knowledge, you know what I mean. So those were the guys that I made friends with. I would pay attention to. I would learn from. There was one guy we called OD at one of my first welding jobs. His real name was Clayton, but everybody nicknamed him OD for some reason. He gave me my first lesson on welding aluminum, as we were a stainless steel TIG shop. I'm veering off topic here, off the script, but it was a stainless steel shop, and so we did everything in TIG, and he was going to give me a lesson on aluminum. And when he set me up to go, that thing just like, it didn't weld, it like pulled away and just blew open and melted open, like it was like from outer space. It was weird shit. And he laughed and he laughed, and he's like, now you know the difference in polarity. And I was like, that was just a little silly way to teach me that, you know, you have to swap polarity and stuff for welding aluminum. Just an odd memory. And like more recently, moving here to the south, I've run across this guy named Ralph, who coincidentally I just took a trip down to his new job to visit him at the last hour of his shift as he was punching out. Really cool dude. He used to work the Apollo projects. Okay, this guy got some fucking knowledge, and he's a cool fucking dude. So I learned a lot from that guy. It just that's how I learned how to do what I do. Anyway, But now that I have established myself in a shop that appreciates my ingenuity, I have begun to build my machine. The design has evolved over the years, and I really think I can get this thing running. I really do. Now, if you study the YouTube videos I mentioned, you will notice everyone removes both of the coils from the transformer and only reinstalls one of them, like the primary, and to generate power from. I want to see if I can get power out of both. I want to leave them both in the transformer and try to get feed from both sides. Hoping that the induction between the coils, which is how a transformer works to begin with, doesn't counteract on each other, and it allows me to get power from both coils at the same time. That's my hope. That's part of the question mark on this experiment. One higher voltage than the other due to the number of winding in each coil, obviously, because that's how transformers work. When these YouTubers spin magnets past the transformer, it induces power outputs that can run a TV, power tools, lights, and that they demonstrate. And again, the real ones are using a small gas motor to spin the magnets, so it's not real free. You got to pay for the gas, you got to burn the fuel, you got to pollute the air. I did build a small model, like an experiment, by converting a ceiling fan motor into a generator, which I learned how to do on YouTube, and tried using an electric motor to spin it. And like the videos, it fails. You spin it by hand and it produces power, and the drive motor was energized, but once you stop turning it, it stopped too. So I decided it was more like a connecting two ends of a hose full of water and expecting the water to flow around. There's nothing to push it. But plugged into the wall, with the electric motor I had hooked up to it, plugged into the wall, it produced 400 volts. I ordered a step-down transformer to convert it to 115 or 110 to use in the like house power, so I could plug stuff in. Because I thought maybe the voltage was why it wouldn't run that motor. It still failed. And that's when I decided to go back to my original idea of moving air. Remember the donut thing? So I tried an impact gun and generated so much power, like it had to be over 1,000 watts, because that I had a multi-tool tester. It blew that thing up in my hand, and it friggin' cooked the coils inside the ceiling fan motor thing there. Broke some connections and made it worthless. But before it did, like I said, that multi-tool lit up in my hand like a friggin' a Christmas ornament or something. Like all the resistors and the diodes or whatever on the board inside, they lit up like friggin' little light bulbs inside the damn thing. They were glowing through the case in my hand. I'm like, uh-oh, and then poof, everything kind of just popped and it was done. Because I spun it a lot faster with the air tool than I did with the electric motor, and that created more voltage than the 400 I was getting when I plugged the electric motor into the wall. So the takeaway was that you need stored kinetic energy strong enough to start the rotation, and once it's rotating, it should power the device, restoring that stored kinetic energy before it runs out. Sound like anything you know of? Like maybe an air compressor? Hence, I was trying the air tool as I was wanting to move air. So where am I? So initially, one must fill the tank beforehand by plugging into the wall. But I suspect in a pinch, if you really had to, with the right fitting attached to the air tank, that you could pressurize the tank with like a hand pump or something, like in a pinch, in a power outage, and you didn't have a full tank, whatever. There's ways you can fill it up without electricity first to get started. Once the tank has pressure, plug the compressor into the generator and use the air pressure to turn it on. Once it's turning, the compressor is powered. And as they do, when the tank gets to a set low pressure, it will run and fill it back up. I did the math. I found a motor for an impact gun and a compressor combo that can fill the pressure faster than the gun consumes it. That's what the CFM rates are. So I'm building the generator part right now, currently, have been for a while. I'm using bigger transformers than the microwave videos. I ordered 6 of those industrial step-down transformers with the coils wound for 115 and the other side for 400. They are also what is called a multi-tap transformer, which have optional ports. Where am I? I just lost my freaking place. Which have optional ports that, thanks to isolated coil partitions, somehow internally the coils are separated into individual partitions and wired together so that you can use one or the both. You know, you can do the 230 line or the 430 or 400 using it all. I can wire the 400 side to be I can wire the 400 volt side of the transformer to be 230 volt. The other side actually has multiple outlines, giving me 2 115 lines per transformer, and I have 6 of them. Wired in parallel, we're talking some amps. Usable amps. The 230 volt side, I intend on powering a 230 volt air compressor, giving me all the 115 extra volt lines as over unity. There's that buzzword, over unity. Usable free energy. In order to pull some amps from this coil, or these coils, I got some hella powerful neodymium magnets with 200 pounds of pull force each. They're like 190 to 200 pounds pull force each. By the math, 6 coils with the 6 magnets can produce a 60 hertz power supply with no circuit boards by regulating the speed the magnets are spinning. Given the top open speed of the impact gun that I selected, I calculated the gear ratio needed to convert the RPM of the gun to create the desired RPM for 60 hertz, without any circuitry. So I do not know if using both the primary and secondary coils will cause a lag or interference or other issues, and I don't know if I can pull 115 volts or 230 volts from the coils until I test it. According to the math, 200 pounds of pull force should be a strong enough magnetic field to induce the desired voltages. If not, I have plan Bs already in mind to correct any issues. I mean, I can alternate and do just single coils out of the 6, do 3 and 3. You know what I mean? And eliminate a coil if they are causing interference, but I can still come up with, I think, enough juice to do what I need, even with other configurations. I have shitloads of other ideas and designs, but this one is the core experiment to prove it can be done. And to really generate electricity free. It's not perpetual, as it will require maintenance and succumb to wear, but no fuel, no fumes, no cost after building the damn machine. It's free electricity. I don't think this scale can run an entire home off-grid, but my hope is it can run like a refrigerator, some lights, during power outages, during storms, winter storms, hurricanes, whatever, earthquakes, whatever would cause a major power outage, and you have to go searching for gas for the generator, I want to eliminate that hassle. So that's the whole idea, basically. In full disclosure, I've been posting progress of the current version build here on, well, not here, but on Facebook. It will be here in a second. Mostly publicly as a safeguard, basically. I mean, if it's out there, and I can prove that it's been out there, and anyway, kind of a soft approach to the poor man's patent. Until I actually get a working model, I don't want to invest in the patent process quite yet, But anyway, I do want to protect my idea a little bit. But I also want the world to have it, dude. I'm going to show you exactly what I'm doing, so you can Maybe you have deeper pockets than I do. You can friggin' use this idea and do it, but just know this is my setup, my idea originally. Anyway, um, where am I? You can scroll through my feed on Facebook. You can check out the QR code above me, and that should take you to all my socials, and you can check out my Facebook, all the public stuff anyway, for those that aren't friends. Um, Progress has been slow because I am tinkering with it at work. Okay, I'm in between jobs and on slow periods and whatnot. Just making sure I look busy at work. Um, so little by little, I've been putting the work in, and I'm nearing the point of the testing process. I'm almost in the testing phase. I'm this close. So if I prove it using house air at work, the system at the air with the big compressor we have at work, if I can use that air and get it to work so I can get all my readings and test these coils and my output, and if it's performing at least the way I want it to, I'll purchase the compressor I found with the right CFM rate to complement the gun I got, air gun, impact. Freaking, you gotta watch what you say now. Uh, and test that for sustainability. You know what I'm saying? So once I know how much power I can get out of the coils, and if using both coils works as I plan, this could be really cool. I mean, we could obviously it could be an emergency generator. That's number one for me. I want to have the free power in an emergency. For you guys into the legalized shit or not legalized, wherever you are, whatever, off-grid grow lamp power supply, and you got all these electric vehicles, these friggin' Tesla charging stations powered by diesel. You're charging your electric vehicle by burning fuel anyway, you know what I mean? Like, what the... So imagine replacing those diesel generators with this idea. It's actually free electricity, dude. And it's pollution free. Other than maybe noise. Air compressor, about the same as a friggin' generator. So there's not much really difference there. But, I mean, so many different uses. It could be crazy. So that's, like I said, this is what I wrote to a friend who straight up asked me, tell me more about this. I like, what is this? Holy crap, what are you doing? Tell me more. So I laid it all out, and I figured, once I read it all back to myself, like, hey, this is actually a pretty well timeline description of what's been going on. And I started going through all my videos in my camera roll, and I tried my best to like gather them all into a folder, I guess it's called on the I can't remember what they call it. And as I said earlier, I don't have enough memory space to, like, say, compile these in a movie editor and put them all in one video, so I'm just gonna share this screen with you. Hopefully the timing lag doesn't really screw things up too much. And I'm going to drop down to the corner and just give kind of a running commentary, correct some spots where I might have misspoke, and explain evolutions in the process, because I explained stuff about it that I changed. You know what I mean? I'll be talking about shit that ain't even part of the machine anymore or whatever, and I'll just say, that I changed that because of... So I'm going to get rid of that, because we're going to have some audio, we're going to have some videos, so let's just close that. We'll stop listening to music, if that was even running for you guys. I don't even know. I'm no good at this. Let's see if we can do this right. Add this to the stage. And again, it's just a screen share of my phone, so it's not really like the full screen size. So if I go something like that. Let me see. Let's make a new one. I can edit this one. There we go. That's not too bad, right? That'll work for this purpose anyway. Oh, I gotta give it a name. I'll change it a little bit. Yeah, we'll save that as a new one so I don't lose the other. So now I gotta go find it and select it. Okay. There we go. Sorry. Anyway, I don't prepare for stuff. I really don't. Okay. Let me just make this larger so I can see what's going on. And by the way, feel free to comment. We got a section on the side of the screen where it'll be really tiny print, but yeah, it'll pop up and maybe it'll help catch my attention so I can actually respond, or maybe not, who knows. But so I'm just gonna dive right in. Like I said, I created a folder of all of the pertinent footage and whatnot, and I kind of guesstimated, added up all the time. We're talking like 2 hours of footage here, so if you want to grab a snack, hang out, or bookmark this and come back and watch some more of it, or whatever, but I plan on being here for a little bit. So let's dive right in. Oh, it went full screen. Whoa. Pause that. I did not expect that. Let's go back to this view. Alright, so this, I'm going to explain right now. This right here is an impact gun. It was like a broken one at work. The tip was broken off, so I was able to weld shit onto it. And that white thing is the ceiling fan that I converted into the generator that I learned how to do on YouTube. I don't want to get into it explaining all that, but that's what I did. So let's see. I think that was right after I blew it up, or right before I blew it up. I think it was after. You can see the welds were snapping. It's really ugly welds. It's painted and it's really, really thin. So it wasn't meant to be pretty. It was just a quick throw it together and see how it works. Alright, we watched that one more than once. This is the damn thing after it blew up. Some of the coils had snapped inside, rendering it useless. It had sheared the mount bolts, so it split right apart. And it fried the multimeter really bad. Like, I did some calculations and I figure at the rotation that I was putting in, at the RPM I was running, I had to have been close to 1,000 volts or more. So I'm lucky I didn't get hit with it, you know. I don't know how many amps, but I mean 1,000 volts. I don't know. But yeah, she cooked. This is one of those transformers I bought originally. The 400 to 115 to step it down when I was running it on an electric motor, trying to get that thing to run itself. I was trying to, because I found out it puts out 400 volts, so I stepped it down to 12 before running it back to the motor, hoping it would run it. And like I mentioned, the water hose, it
been getting 60 hertz.
Let me start that. I forgot there's audio.
Alright, so some of you might recall me buying these transformers for one of my earlier experiments when I was turning my machines at 900 RPM. I was getting 400 volts.
See,
not realizing I was spinning it too fast, and I was getting more than 60 hertz. If I'd slowed it down to where I was getting 110 out of it, I would have been getting 60 hertz. I was getting more like 400 hertz at 400 volts or something like that. So even with my step downs, I wasn't going to be usable power, because the step down doesn't change the frequency, just the voltage. So I've got these two big ass transformers that I don't need.
Not to mention the way the coils are set up inside a ceiling fan. It was most likely, if it was anywhere near 60 hertz, the alternating currents from the magnets being swapping poles inside that I put in there, they would never have been synchronized. They would have been so out of sync, out of phase is what you call it, and that's probably why it locked out. Now that I think of it, I just thought of that. It's probably what locked it out when you try to run itself, because it was out of phase.
I decided to go big. I just ordered 4 more of them, so I have a total of 6. I'm gonna bust them apart.
They were expensive too.
Separate the primary coils and the secondary coils.
Yeah, and I purchased those extra 4, like maybe days before that tariff bullshit started, and after I got my order and paid for my order, I got friggin' notifications from FedEx that I owed all this extra money in friggin' tariffs and port fees and shit, which I have never seen before ordering anything online from anywhere. So, thanks for that.
Different configuration. And I'm going to buy some high power magnets and build my own friggin' stator and rotor. And make a nasty one. This thing's going to be big enough to do what I want to do.
I hope.
And if it's not, I can always take the coils out, buy
Plan Bs,
wire, and make a custom coils out of these cores. This is what I'm really after right now, is the cores to build my own custom stator.
Yeah, because that laminated friggin' steel, it's a special kind of steel. I can't remember what the hell it was called. It's some kind of, I can't remember how it's like magnetic coating. I can't remember, but it's a special type of steel, and it's laminated to reduce the eddy currents for the loss of flux. Something like that. I'm not an educated man, but I do kind of understand some things sometimes. Anyway.
So with 4 more, I can arrange them in a pattern of 6. And do some math and figure out how fast or slow I need to rotate this thing to get the voltage and stuff I need. But with the bigger coils and much bigger, stronger magnets, I'm going to get a lot of amperage, which means I'm going to be able to run a lot of different devices.
You can have all the voltage you want, but if you ain't got no amps, you ain't running shit.
Friggin' refrigerators, TVs, friggin' heaters, probably, you know what I mean? God only knows what once I get all 6 of them. So
voltage, current, and power.
I'm going all in this time.
And
hopefully the 4 I ordered aren't bullshit. They looked identical, the tags on the top are identical, all the specs. The only thing different...
Yeah. Anyway. Yeah, let's watch this one. This one's sped up. So in order to get the coils out, you got to cut that top piece off. I had to take them out, even though, like I said, I'm going to use both coils. I still need to take them out because I don't want to damage them when I weld these cores into their mount and everything. So when you see in the rest of the videos without those cores and the coils in there, it's because I'm still in the building process. Once it's ready for wiring, I can slide them back in. And you gotta be really careful. Those laminated things, they split right apart. Like, I've seen people beating on them with a hammer trying to get that coil out, and they destroy the most important part is the core. without the core, you're not inducing much power. It's the interaction between the iron and the magnetic field that pushes the friggin' atoms around, or whatever, the electrons in the friggin' copper or whatever. Anyway, so don't beat on it with a hammer. Make sure you like use wood. That's so loud, and it's playing again. And this is, I believe, yeah, that's the one I used to edit that video. Anyway, which one is this? It's not playing. Why won't that one play? What's that exclamation point about? Huh. Interesting. Anyway, so I don't even remember what that video was. I'll have to make a mental note and check that out after the stream. So here, the first two, I got the tops off, I got the coils out, and you see that piece of wood. Don't hit the core with the hammer. Use a block and hit the wood block instead, you know what I mean? Be smart about it.
I don't want to give away exactly how I'm doing everything to everybody.
Well, that was then, this is now.
Again, with the compromise thing, trying to make something that I can afford and actually have it do what I want to do. I was having trouble finding the power source to rotate it. And my idea is to use a compressor and some kind of air tool to spin it. My problem was finding a combination of compressor and tool where the compressor could keep up with the tool or fill up faster than the tool uses up the air, so that it never runs too low, so it can run continuously. And it's just serendipitous the way this worked out, or it's gonna work out hopefully, because the transformers I bought before, they're called multi-tap.
Excuse me.
So, well, that doesn't matter for this. Anyway, but because I'm using transformers, okay, and I plan on using both primary and secondary sides to get
Hopefully.
full output.
Hopefully. That's my theory. That's what we're testing.
I was hoping that, that one side's gonna be the 230, the other side's gonna give 115, and I was hoping to use the 115 to run a compressor that could handle an air tool to turn it. Unfortunately, I can't find a combo of 110s compressors that would keep up. Because I was hoping to use some of the 110 amperage and have some left over, and still have the entire 230 left over to do like the AC unit, stove, dryer, you know what I mean? Kind of full house kind of deal. I might have run short on the 110 line, but you know what I mean? You'd have to regulate whether you're gonna run, your dryer, or you're gonna cook, or you can't run it all at the same time. You know what I mean? But like I said, it wasn't gonna work with a 110 compressor. But then I found a 220 compressor that will keep up with a certain air gun that I'm looking at, and then some. And it's serendipitous that I'm doing it this way, because now I've got the whole 230 side I can use to make it run the air that turns it, while at the same time the other half of the coil is giving me all of the fucking 115, 110 line to use as extra. And with the amperage ratings and whatnot, if I get what I want to get out of it, running the compressor won't use all the amperage, and I still have some 230 line to use for an appliance as well, if there's enough to run the appliance, you know what I mean? So
I touched the screen. And we were right there, and it was about over anyway. So this is the air gun that I have purchased. I already have this one. The one I showed you earlier, like I said, was one at work that was broken. I asked if I could use it because the socket connect, the tip there, where the socket clips on, had sheared off, and it was just sitting collecting dust. I was like, hey, can I mess with that? And they let me have it. So this one I bought brand new, so that I can take it all apart, get rid of the handle and the casing that we don't need, because we're just going to use like the motor, we just need it to function. It's not going to be a hand tool anymore. It's going to be solid mounted on the side of this machine. That is the compressor that I believe will keep up with that gun. Okay, that's an overhead shot of the coils before I took them out of the cores. It's just a still shot of some more demonstration. Actually, I'm like trying to size it up and see what kind of radius I'm looking at. Before I got the other 4, I only had the 2, and I was trying to figure out measurements so I could start building it before I had all the pieces and knew how big it was going to be.
Full disclosure,
I use that a
I'm
lot
not gonna
apparently.
share all these details with anyone right away,
Apparently I am.
but so I get the idea down and don't forget. I fell upon some more serendipitous ideas. For efficiency, instead of setting this up
Oh,
the way I've shown in the pictures in the hexagon with the opened ends facing the magnets, the effectiveness of the iron core is more important. So to cover more surface of the iron core with the magnet as the magnet goes around is more efficient, generates more, as well as being on its side rather than the magnet passing across the top of the coil. These coils are stacked. And if the magnet, if these are sitting this way around a circle, the magnet is only passing the top coil at full force and not as much with the bottom coils. And I'm trying to get power from both coils in this transformer. So I decided it's also better for the magnet to pass by in close proximity to all the windings on one side of the coil rather than just the top of the first few windings. So this is a design change compared to the YouTube videos to increase and maximize efficiency and output. So that covers how I've modified this, and why and how I'm using all of the coils. I'm not taking anything out of it because it's my understanding that, what do they call it? They're called multi-tap transformers. Notice there's multiple inputs. The input side, you can select either or, but not both. Of either the 4
again, I've described this already in my intro.
You wire it to the 230 side as a
But what I didn't mention, I believe, in this video, I changed the rotation. Compared to the YouTube videos, they got the E shape of the transformer, all facing each other around in a circle, and the magnet spinning around across the tops of all these transformers. And like I said, when it does that, it's only passing by the top of the coil. So what I'm doing is I'm going on the side so the magnetic field passes every winding. It gets the same amount of push as the magnet goes by. And I've also, which I didn't mention in this video, is a second rotation to it. It's on its side and turned a certain direction, because as the magnetic field passes the coil, if the coil is going around, like say this way around the circle, you want your magnetic field to come perpendicular to that, and instead of parallel with it. Because if the magnet passes by in the same direction the wire is going, it doesn't do anything. But if you turn that wire perpendicular to the direction that magnet is passing by, and then that's how it pushes electricity. Okay, and so rotated so that it's not passing by the top, it's passing by all the windings, and orientated 90 degrees to the passing magnetic field. That is how mine is way different, and hopefully going to be a lot better than any of the ones you see on YouTube. And I guess that's pretty good for that video. Alright, alright, these are some experiments I've done that it's like a little secondary project I've got on the side. Because I still wanted to continue working with the ceiling fan things. I want a small version. And I've decided to get away from a motor trying to turn it. I found using magnets I can make this damn thing spin itself. So if I have converted the inside to be a generator when it spins, and then on the outside have magnets set up in a way that make it spin, that's all it needs and it's done. And I think, short of building the contraption, I demonstrate.
Did an experiment, and I think it blew my mind. So here it is. I've got a fan motor, simply because it has bearings and spins pretty freely. Okay. I've got these are just speaker magnets that I pulled apart. 3 of them on there. I've got a 4th one in my hand. Now, I don't know anything about gearing, but I'm pretty sure if you spin this, you can gear it to make an arm go back and forth in the correct timing to do this. Oh, I got too close.
So a geared 3-to-1 ratio.
That's geared. Correct timing.
Why not?
Wouldn't that be a perpetual motion machine?
Other than needing maintenance but yes, that's pretty much what I think I'm on the verge of here.
So all I need is like some Technics gears or something to get the timing.
I have worked out a design. I am working on it.
As it goes faster, I'm trying to keep up and I can't. That's why I need gears for timing this.
Alright, anyway. Oh.
I got a package today.
The big magnets. Not even out of the box and friggin' shit's being drawn to those magnets, dude. There's no joke. They are no joke. These are dangerous. I gotta be very careful when I handle these things. Anyway, oh, you can see the split in that transformer over there.
3 came in the mail today. 3 more to complete the circle.
Like I said, they split apart really easy. And okay,
So I mentioned my first experiment blowing up my tester. Don't
oh
believe me?
man, the audio is way off on this now. All of a sudden, I don't know how that
This is
happened.
the dial, it switches it to the different settings.
And yes, these are going to be somewhat out of order apparently.
Fucking cooked it.
Like I said, at least 1,000 volts went through that. There had to have been, or close to it.
Yeah.
Okay. Just another still shot of probably some of the new ones that I got in the mail, taken apart, against my fist for size comparison. Oh, here's some more of that experiment I was talking about.
Self-propulsion test. Two pistons. 1 wheel.
Forget the piston idea, by the way.
Two
It's,
pistons in time.
I made it better. Or I'm going to. I have the design that works better.
2 strokes per magnet on the coil.
That's pretty cool, though, when you think about it.
On the rotor, on the spinning part.
And you see all these weird walking machines and all. You know someone can gear this to do this. You know that. Like how is this not even a thing already? You know.
So close and how fast I can get it.
Anyway. So here's the new design of that. This is full disclosure. Here it is. This is 3 bicycle sprockets. Okay. One of them is mounted to a ceiling fan motor, which has been converted on the inside with magnets to be a generator. It has the larger magnets on the outside. Okay, and then the wheel in the middle. I'm talking about the 2 with the arrows with the rotation here. The one in the middle on the outside of the chain has to be on the outside of the chain to continue the correct rotation as the chain goes by both wheels, okay? And that second wheel, it has a set of bigger magnets on it as well, set in place so that as it goes around, it's timed to be in just the right. Each one is going to be in the exact right spot to repel and push the magnet on the other wheel. The third wheel is simply an idler pulley so that you could put the second wheel on the outside of the chain loop. So that's just a free spinning bearing, no load, no draw, you know what I mean? No real weight, no force, and with strong enough magnets it wouldn't even matter because these things are going to push. So instead of pistons, I have a second gear beside it that rotates with it and has them pass in the right spot. Dude, seriously. And again, once that's doing its own thing on its own, pushing itself around, there's a setup on the inside of that first one generating power. So again, the coils inside a ceiling fan motor are wound differently. Like they're either seriesed or paralleled, and I believe they're DC. So putting magnets inside it and alternating polarity with the wrong configuration of coils and this and that and timing, I still need to work out the logistics, but it does produce power. I just need to know how strong, what type. You know what I mean? Is it AC? Is it DC? Is it out of sync? You know what I mean? Is it out of phase? Does it have any amperage? Those sort of things. But I will have this thing spinning on its own and generating some sort of voltage out of nothing with no force, no power, no fuel. Here's another. You can see in the background. You can see in the background, right behind that magnet, there's another ceiling fan motor attached to an electric motor. That was the second one I built, because I tried at one point building two of them and trying to cross wire them, have one run the other one, hoping it would stop locking each other out. Didn't work. And the second one I made, actually being probably a different brand or a different model, the windings and the wire quality or whatever on the inside was different, and I wasn't getting the same voltage I was out of the first one I made. So I was getting two different outputs from these things anyway. So there was another failure.
If you time it in between them,
I still have that one. You can plug it in and I can show you the output. It's crazy. But anyway, yeah, now with three, with just one,
stronger and a lot faster. A lot faster.
say, but all I'm doing is simulating basically a magnet going by it. So that's when I stopped thinking about piston and started thinking about another wheel going by. Started thinking like planetary and moons and gravity and the pulls and how things line up and push and pull, and I don't. That's just how my brain got to these concepts anyway. There's another one.
If I make some kind of a rocker
Another idea that would
triangle.
Scrap that. We'll just do the gears. Scrap that. And here's the example of using the wood. I think I had to pry this up out of the way just so I could swing at that coil. The coil is locked in the top one. It's like glued in. So I'm using the bottom one as like a stand so I can knock the other one down out of the top one. And I know, I think I'll just knock it back into another one. The other one won't be glued. And once I get it down in there, it'll slide back out, no problem. But I believe I take a piece of wood.
Luckily, I was able to get one out.
I hope. Please tell me I used the wood.
Stuck.
Thank you. See? Instead of nailing that shit with the hammer, use the wood, dude. I know in the video I said this is gonna be like 2 hours. We're already an hour into it. We're probably not even close. I'm skipping stuff. So that's basically how I did that. I did that to 6 of them, cut them all out. And I don't know if I shared any other information in the video or not, but I've already told you everything anyway. So moving on, because I just want you to see some visuals. This is me trying to visualize the configuration, trying to figure out which direction, how to mount them, how big the circles are going to be that I need to mount them in. Boy, that's repeating like a GIF. What is that? Okay, anyway. Same idea, just getting a visual. I'll sit there and stare at something like this for like 4 or 5 days, and my brain is just mulling over, I don't know, an astronomical amount of friggin' information, trying to figure that, like, how things are going to be and what will happen, what will this do, what will that do, what do I need for this, how am I going to do this. And I got to say, like, ChatGPT was actually very helpful. I mean, I don't trust it 100%. I had to, like, back check and double check and the math and stuff like that I asked it to do for me. Make sure its formulas were correct. Make sure it actually did the math right. Make sure it understood the concept of what it was trying to calculate. Because sometimes I get wrong answers. It just wasn't. It was weird, but it's just about my process. Here I got the full circle. Now I got all 6. I think that was just when as they were coming in the mail. Got them all open. What is this?
4 speaker magnets.
Oh yes,
I
I
took the little magnets out of the ceiling fan that blew up already.
yeah, I disassembled it.
Set up alternating polarities.
Those are the little magnets I put inside it that made over 1,000 volts.
Speaker.
Those little
What happens when I turn
half
it,
inch
you
by
know?
half inch by eighth, fucking thick, just an 1/8 inch.
Like, get them to land in the right timing, the opposing poles every time. It just keeps turning it. Now, if it's on a chain, they'll turn each other. So
See?
turn the inside of that it's spinning on into a generator, like this one was before it blew up. I'd have 2 of them making free power, turning them on their own.
Yeah, so if I do that with 2 ceiling fan motors and have them both spinning each other, I have 2 outputs, right?
In between, one is pushing while the other one is pulling in the same direction. So one's attracted to it and pulling towards it while the other one is being opposed and pushing away at the same time. So it's always, as long as you gear it 1-to-1 ratio and time it so it lands in between every time, it'll always turn it. 4 speaker magnets.
So there's another idea I got thinking about, like why just have one if you're using 2 sprockets and you're spinning them? Make them out of 2 ceiling fans. So I got sprockets to mount on the ceiling fans, and anyway.
Going corner to corner, I think, is going to cause an issue with the coils. So I'm thinking about just taking these and cutting them to match the height and welding them in between each one. You know, stand them up and weld them in.
Don't need the welded tops in there. They don't need to be connected to each other. They're all going to be welded to the same damn piece of steel anyway. They're all connected at that point. I mean, technically. And I don't know why I thought they'd had to be a transformer when it's got 2 sides and the middle and it goes across, so it's a figure 8 basically going through these coils. It's like basically 2 vortexes of friggin' eddy currents from the flux lost in the induction process and through the loss from heat and all that physics crap. But the spacing is about accurate to what ended up being.
Complete no circle around.
So I'm getting a better idea of the size, the dimensions.
That's 13. Somewhere around probably 14-inch ID right there.
I think I got it down to
What I'm probably going to end up working with, which is
12-ish, because my center is 10 inches.
I was anticipating.
The outside is a 24-inch.
But I think it'll make it easier when I make the rotor. I'm kind of scared. These magnets are so strong that when I'm trying to mount them on whatever this rotor is going to be, a real small one, like I had planned on, somewhere around that size.
Yeah, big difference.
Put one magnet on, try to get another one on. They're so strong and so close. I'm never going to be able to get it mounted on. They're so strong that they're just going to flip and snap together. So I think the corners of the coils being a little too close together is kind of a serendipitous blessing. That if I use the core tops to extend this circle around and keep the iron core all one piece, I can make my rotor a lot bigger, and that'll give me a lot more space to mount these hardcore magnets. Be a lot further apart, maybe a little bit more manageable. Still kind of concerned.
Yeah, it didn't go like that. That's not. Yeah. What is this? The same video? No, can't be. Oh, I think I put them.
Cut these to match the height and weld them
Yeah.
in.
Anyway, same idea. Just visualizing the scope of the whole thing. This must be the with two
I
sprockets.
ordered some sprockets, bike sprockets, so I can start gearing this and see if, with a chain, if it continues to rotate itself.
It's very
And
cool.
if it does,
I think it's gonna work.
then I can just place a coil beside it and have free electricity with no motor.
Yeah, anywhere there's a magnet, you can
This
just
will pull itself.
you can just friggin' plant transformer, coils all around the friggin' circumference of it, because there's magnets on it spinning around too. There's another source. You have coils coils inside, coils on the outside. It's gonna be friggin' bigger than Tesla. I don't know. Oh, here we go. This is the opening of that magnet box from earlier in the video. They put it in a sheet metal box inside. You know what I mean? It's like held itself closed. That's how strong the magnets were. And the whole box is lined with metal around the sides and the bottom too, with all that styrofoam inside it. It's not heavy, it's just pulling against the steel in that freaking box, dude. Yeah, watch this, me trying to pull one apart, dude. You're supposed to make like kind of like a paper shear out of wood on the edge of a table to separate these, but obviously I have not done that. That is not overacting. I was literally struggling that friggin' hard just to spin that. Yeah, it almost caught my finger in between that piece of plywood there. So I flip it up on its edge, and I still gotta pull with all my might and my foot to get it off. Those things are fucking awesome, dude. I can't wait to install them and see how much of a pain in the ass it's gonna be. Yeah, those are the.
This away because I don't want them to
Let's
smash
see.
it back.
I got a cigarette pack to kind of show you the size difference.
Size. Okay.
Should be another one. Yeah, this is the little magnets that I took out of the ceiling fan that blew up. This is what I used the first time.
Comparison,
Look at how small it is.
This is what I used for the magnets in my previous experiment, converting a ceiling fan motor into a generator. 1/2 inch by 1/2 inch by 1/8 inch. Okay, 16 of these generated over 1,000 volts in a friggin' ceiling fan and blew it up.
No lie. No lie.
For comparison of what I'm about to attempt.
Think about that. That little one created over 1,000 volts. Think about that. These ones are going in the new one. Yeah, who knows what could happen.
Alright, I'm going to attempt to safely put this.
Oh yeah, because you don't want them to slap together because they'll shatter, dude. So I was trying to get it back on the stack without
How I'm going to pull it off.
losing a finger or a magnet. mean, I'm struggling to hold on to it. It's pulling down onto that styrofoam.
That was too close.
Yeah, it just smashed my knuckle into one. It was so close, it bashed my finger. Like, almost got me. Almost.
Oh. Wow, I can just feel. This way, it's a.
I'm just so scared to let go because if it drops too fast, they'll slam together.
It's trying to get there. It's trying to fly out of my hand. It's like pushing and it's like throwing it. I've got a death grip on this thing. You have no idea. I'm just trying to get it to contact it really gently so I can slowly ease it back on. And the first time I did it, it friggin' flew out of my hand and smacked into it. And I'm so afraid I'm gonna break them or lose a finger. The staff is in there. It's got this little piece of plywood to block them from actually making direct contact with each other, which kind of helps. I'm thinking maybe if I could just slide it down on the styrofoam and spin. I don't know. Oh, Jesus. It just sucked right into my hand. Oh, did you see how quick that snapped on? It's trying to twist now, too. It's going to fly. Boom, it just flipped. Pinched some of the styrofoam, but I got it on there without it smashing on like last time.
Yeah, those are some scary friggin' magnets. I have to be really careful when I start putting those in, and that's coming up next. The next stage of the build, is mounting these magnets. I've got everything. The rest of the build, for the most part, I'm ready to start assembling the the biggest part of it. Anyway, I'm so excited I can't even talk. So there's more of me trying to visualize the size, the scope, orientations. And this is not the orientation that it goes in, I don't believe. You'll see in a moment. And I haven't decided if I'm going to need to put them back on the top. Because in a transformer, it needs the circulation to work. But I'm not inducing from one to the other. So I'm wondering if it would be more actually helpful to leave that off and reduce any negative reaction I would have of them having power to both. Anyway, that's what I'm trying to figure out when I get the testing going, is how the two coils are going to interact. Because in all the other YouTube videos, when they do these microwave transformers, they pull the coils out, they only put one back in. I want to put them both back in and get power out of. I want to utilize more. Why would you reduce the amount of power you can make if you have the extra coil there? You know what I'm saying? Alright, here is the actual configuration. Okay. Notice how I've got them tipped on their side as well. So that when the coil goes around inside there and then the magnet spins by it, the magnet is spinning by that back side of the coil 90 degrees to the way the wires are running. So I'm hoping that'll make it more work better, more apt to be a success is what I'm looking for. Anyway, what is this video? Oh yeah, this is with me. I get another serendipitous thing. I work with pipe, and this particular combination of pipe sizes fit 24-inch on the outside, 10-inch on the inside, with that much room to spare so that the magnets don't hit the cores. So it's a still shot of the configuration. Using like a photo editor or whatever to kind of conceptualize cutouts and me like trying to like if I do put the tops back on, I'm gonna have to chamfer the ends because of the angle of the radius is gonna block it from fitting to the edge. It's going to push out the edge too far. So I'm not, right now, I'm not using the tops, or I'm not going to be. There's the inner and the outer tube, basically the stator and the rotor. Is what I'm going to start trying. I got to start trying to use these terms. So like all the science Nazis out there, like, oh, like I said, I don't know a lot of things, but I do know a little bit about some stuff, you know. I may not be educated on it, but I have read up on, researched, tried to understand on my own some of this crap, okay? It's more a visualization of some cutouts, because these pipe are heavy. I'm trying to bring the weight down. Even the plates you'll see later on that go on the sides of these, I'm gonna end up cutting out like sprockets, like a tire rim, to remove some of this friggin' weight, because I can't even lift this thing right now. I have to use a crane. At this point, I want to say, duh. I cut these squares out of the big pipe by hand when I'm the main operator and technician for a friggin' CNC pipe cutter. Hello? When I went to make the smaller one, it dawned on me, and I made a program and cut the smaller one on the CNC, but this one I cut by hand. So I hope my measurements were right on, you know what I'm saying? With a plasma cutter. .85 amp, I think. It's either 85 or 65. I think mine's an 85. I just used a piece of flat bar and clamped it on the edge to ride along with the torch, and cut straight lines around the radius, and then clamped a straight edge across the pipe to cut the straight line the other down the length of the pipe to cut these squares out. Me doing measurements, we don't need all this noise. Yeah, this is what I do for work. Stuff like this. Not exactly like this, but you get the idea. And so there's the result. There's one of the, cutting these squares out. By hand, like an idiot. When I got a friggin' CNC machine friggin' 10 feet beside me right there at that station. Some more configuration layout, probably duplicates. Okay, this is with the holes actually cut out now, starting to take shape. You know, you see, and it's the middle. The one in the middle is the one that spins, not the outside with the holes in right now. It's the one in the middle that's gonna spin. There's more shots. I just like the way it looks. What did I do here? Oh, this was another visual rendering, combining photos of before I welded them in to see what it would look like, using a blending tool to kind of overlap the images and see. So that's the concept right there, is to get those transformers in there, basically. Like so, a better rendition. I took my time and did, like the erase the other parts that weren't supposed to be there, and made it an actual single image. Checking the fit to the middle pipe. And what was that? Oh yeah, and I didn't have to, but I polished the inside of that whole damn thing afterwards. kind of ridiculous because over time that's just going to rust. It's carbon steel. It's not stainless, which I wish I wanted to make it out of stainless, but we didn't have any in stock, so I had nothing to work with. So the whole thing's going to have to be grounded like crazy. It's going to be really magnetized. If you've got heart technology surgically implanted, like my father had a pacemaker or whatever, probably won't be able to get near this. And I do have an app that'll read like the magnetic fields and shit like that, so hopefully I can get some readings when it's up and running and kind of determine like a safe radius and just you know, just because it's really neat. I'm intrigued by this. I can't believe I'm actually building it. Here I am fitting them up inside the damn thing, getting them tacked in, trying to keep them all in alignment as accurately as possible, so that, as I mentioned before about phasing with the north and south poles, they need to pass each other at the same time so that the phasing stays in sync. You could have 3 or 4 of them going off at the same time and they're all, you know what I mean? It'd be, they have the sine wave has to be in sync. So I took my time. I tried to make sure I could get in there as close and straight, as accurate as possible. Worked my way around, got them all in there. And that noise is the friggin' air filtration system for the CNC is right beside my station. Well, that's the big giant fan motor you're hearing. It's like the kitchen exhaust vent on steroids right behind me in this shop, basically. Alright, so now here I am actually welding them in. They were all tacked in and fit up. Now I had a moment to weld them in. And it's not the prettiest welds, because that is that laminated material. It's got that lamination. It is what it is. I mean, a couple of them welds, if you look real close, you'll see some porosity or whatnot. That's from, you know, contamination of the lamination. It's also, there's a coating. It's got this kind of greenish tint to some of the steel on the cores. But all in all, it melts out. You know what I mean? And trust me, it's solid. They're not going anywhere. So, it's me just spinning it and keep trying to wipe the spatter and keep it clean on the inside because I polished it. Doing all the welds. That's me getting the cores welded in.
I don't know. Just gonna run it. Fuck it. Run it.
I think that's me complaining about the porosity and the lamination. Like, screw it, just run it. Okay. So that's probably me doing more of the same, or maybe it's even the same damn video. I don't know. Nope. Okay, this one does some close-ups. Here we go.
Now.
They're not the prettiest, but they're not bad either, you know what I mean? Still actually pretty architectural. They got this nice stacked puddles.
Porosity. Yeah.
And you can see the spots where it was splitting, and I kind of tacked them together on the tops. So so that they wouldn't come apart on me.
Something to do with the lamination.
I'm just repeating myself now. So there's another shot of it. Ooh. And still, I'm a shutterbug. Alright, now we're working on the plates, and I gotta get that hole in the center. Right in the center. It has to be absolutely as centered as possible. I don't want any wobble. Sorry, I don't want any wobble while it's spinning. You know what I mean? It's gotta be as dead nut as possible. I'm getting tired. Oh, what's this one? Oh, it has music to it. Nothing you haven't already seen. It's just sitting in there. How long is this? Oh, it's a compilation video I made when I still had some memory space of me putting it together and showing you what I just showed you. Okay, so here's the one of the sets of center plates. I set that on the edge to test how much it would wobble, to keep an eye on that gap. That's pretty close. I mean, that's not bad, man. Pretty much dead center. Okay, here's what I was telling you about the CNC machine. I should have done this to the bigger one. See, these are the cutouts where the magnets are going to be in the center pipe. So I wrote this program and just popped it in the CNC and didn't have to worry about cutting it by hand, man. And if you want to learn more about this machine, go to my Facebook page. I just dropped a link to a commercial we filmed, basically endorsing this machine for the manufacturer of this machine. So use the QR code, find my Facebook, and go check that out. It's like one of the most recent posts, actually. But this is the CNC machine that I take care of, basically. Try to. But that was so much easier than doing it by hand. The only problem is I couldn't get it to cut straight corners. It would only do the rounded corners, and I had to file the crap out of it and open it up a little bit. My what am I trying? The word I'm trying to say. I always do this. I lose my vocabulary when I get excited about shit. Yeah. Anyway, I didn't. I'm getting stuck on the damn word. I didn't account for the width of the flame enough when calculating the size of these holes. So I had a fun time trying to grind and file them open enough to do what I needed to do. Let's see. It's just more footage. Okay, here's the top piece. Yeah. So that's how it's going to spin. That plate is what attaches it to the shaft that spins that center wheel. Okay.
Here's my mock-up magnet.
Yes, I cut that to match the size of the magnet so I could start fitting these up, getting them ready. And that's how the magnets will be mounted in. Like I said, after I get them in there, I got to find a way to, like, close off behind it, make like a little flip down tab or something that keeps it from falling back out backwards or something. But there's a YouTube video I was showing people where the guy actually fills his with like an epoxy and that holds everything in place. I've been considering something like that once the magnets are in. I don't know if I want to. I don't know. One of those things I'm thinking about, still in the design process as I'm building it. That's probably not a good idea. That's why it's taken so long too, because I'm going slowly. I want to really overthink everything as I go and try to factor in as many variables as I can and take care of them beforehand, so I don't have to tear it down and rebuild it and keep changing shit. Yeah, more of this, more of that, more of that. We're skipping along. There's one of the original experimental ceiling fan ones I was telling you about. This one had a lower output I wasn't too happy with, but I still have it. There's some things I still want to learn about this, like why it didn't work, what exactly type of power I need. What I want one of those sine wave meter thing. What the fuck is that called now? I forgot what the hell it is. It's a tool, a testing tool, whatever I can hook it up to and see the actual sine wave and tell what frequency it is, and you know what I'm talking about, oscilloscope kind of thing. I don't, but I need one of those so that I can get more information with my experiments. Because right now I'm just inferring and guessing from the results, you know what I mean?
Hey, it's been a while since I've given any update on the generator. Sneak peek, sneak peek. So where I'm at right now, I need to make the frame with the center hole for the whole thing, so this sits in the center and keeps me my good gap here. I don't know how well you can see that in this light, but I barely have a gap, which is what I want. I want it as close as I can without it actually making contact. Now I can basically gonna build a rim for the big piece with a hole in the center to match. That's a pretty big piece of material, so I figured I better ask. So I ended up paying. Why is that so? Hold on. A little better. Hey, it's clearer. So
Yeah, up until that point, I was building it out of scraps and shit that was being thrown in the recycling bin, and you know what I mean? So this is an actual larger piece of stock or inventory, so I had to actually ask for it and paid for it and have a receipt for it.
on myself a plate. I gotta cut it down the middle, cut 2 circles, and find the center hole. And I'm gonna make it so it bolts on, like a rim. I get some like nuts and bolts.
Which is where I'm at right now.
Nuts to the inside edge. So when I put the plate down and the hole through it, I can line it up and bolt it down. That way it can be assembled and disassembled instead of welding it in permanent and closing this all off. That will be the next step.
Kind of.
Awful blurry. So 23 3/16. The size I need to make a rim.
Close enough.
23 1/8, 3/16 to 1/8.
Close enough.
That should fit real good. No grinding necessary.
Now, there was some grinding necessary, but that was just to make them match better. There's me. My first attempt at building a bearing and bearing mount for the middle. But I ended up finding a better bearing and tearing that out and putting a bigger hole. Oh, this is a view from inside the friggin' rotor. They look like little window shades, don't they? I think that's good. Anyway, moving on.
Here are the little ones I was talking about. The rollers inside there are so damn small.
So I thought roller bearings would be better.
Not as industrial as I was hoping it looked compared to this.
Yeah, on the internet it looked a lot better.
So, see, this is the one I tried to tack it on. You can see the roller. Obviously, I fucked it up.
Yeah, it's a lot smaller than I anticipated.
Try to take this one out and make a hole for this to fit this larger size spring right here, this size. I don't have a punch or a drill bit this size. I'm gonna try to center it on my plasma jig and try to burn it. I try to burn it a little small, so I have to grind it and make it sit, but I gotta try to keep it centered.
Yeah, that was tricky. And I had to do it twice. I did make both of them match.
If I get it just right, I gotta burn out the other one and get that ready at the end of July when the other bearing shows up on back order.
Yeah, there was a back order on the bearings. I had to wait forever for the other one.
TIG welds off.
Yeah, I bought a new TIG welder. I brought it into work and tried it on here. Since my the breaker in the garage doesn't run the right amperage, I got two brand new welders. I can't even use them. I had to take it to work to try it, make sure it worked.
From punching a 2-inch hole, and I punched the right size hole for the outer side of this. It was really tight, and hammered it into that friggin' slug from a 2-inch.
So that's just me tearing apart my first attempt. Grinding out my welds. Snapping the washer that I put on there off. And comparing it to the one I bought. Look, I pretty much made it the same as the one I ordered. Which is pretty weird. Well, one's roller bearings and one's just ball bearings, and the ball bearings are actually the industrial one. So, and it was smooth.
Get my plasma rig set up, my little turntable I made.
I don't know if I filmed that or not. Got that cleaned up and ready to go. Because that's got to fit in there.
I gotta get that in there.
Alright, moving on. Oh, I did film it. I did. Oh, but it's going the wrong direction.
I've marked where I want the line to be.
Hold on. Since I'm here. Try that again.
Alright, I'm all set up. I've marked where I want the line to be. Kind of eyeballing it to the center of where the plasma beam will be.
There's me trying to calculate for the width of that flame again. It's called a kerf, by the way.
Fingers crossed that it's right, and fingers crossed I can get a second one on there. Here goes nothing. Let's pull this trigger.
So I made that turntable. I made that whole machine from scratch. And that's the second one I made. I made one for another company before I started working here.
Slow and steady.
Yeah, I made that machine. It was pretty cool because I have used that a shit ton, man.
I think I so that slag's stuck in there. I think I made it all the way around. Now I can only hope that hole is close to the right size. I want to be able to open it up a little bit with a grinder and make it fit perfect.
It wasn't. It was a little too tight. I ended up
We shall see.
putting it back on the machine, realigning it, and cutting it a second time, a little bit bigger, and then cutting the second one to that same measurement.
Well, one of them came out pretty good. I figured I'd get the other one set up on there without moving anything.
Oh, that's what happened.
Centered, it should be just right. I must have bumped the damn arm with the plasma on it because this one ended up like a ½ inch too big. So now I've run a couple of passes of weld with the MIG gun. There's the gloves. To close it back up, I'm going to grind it out and then like tack them together and try to match them up.
I remember that now. Yeah, that was a pain in the balls, but it worked.
We'll see.
Yeah. I learned that trick by watching like machining videos and stuff on YouTube, on Facebook, where they run weld and a shitload of layers of weld over something and then return it in a lathe or whatever. That's what gave me the idea. It's like, well, it's too big. Well, shit, I'll just run a weld pass around it a couple times on the inside and make it shrink it up and then grind it back out to the right size. And it worked. Here's me making sure it's centered, trying to grind the ends to match so the outer diameter was exactly the same, and testing that first bearing that came in the mail. They're both clamped together and running off of the one bearing, and I'm not spinning it. For some weird reason, just the weight of the way the configured handles of those clamps are, it just kept spinning itself for a long time, almost like a perpetual motion machine its own. It was pretty weird. It just kept going. I was like, what the hell? That one's a duplicate. Yep, duplicate. Okay. Now I had to cut this one down and make it smaller so it fit inside the other one. You notice before they were both pipe were the same height, and I couldn't cap the big one off because this one would be in the way, so I trimmed it down to fit in the center of the other one. Anyway, so there's the big plate fit in. I got the shaft fed up. I got that in the center. See, like I said, all I gotta do now is put the magnets inside there. And this is just dry fit. It's just being held in by friction right now. Nothing is welded or bolted or anything. So the plates are a pretty good fit. So yeah, and I gotta hope and pray those bearings end up being dead center, or that the one in the middle is gonna make contact. You know what I mean? So at this point, I only had the one bearing, so I had the other side of the shaft sitting on like a pipe stand, and I had it leveled out so I could at least test it and see what was going on inside. See how that's why there's so much wobble to it. It's only on a stand. Oh, that one's not even on a stand at that point. Okay, my bad. Just a still shot of the bearing. Okay, comparing. Okay. Oh, and I added this. I made this little collar. I drilled a hole in it. I tapped the hole, and I bought the set screws. Now, when I'm all said and done, I gotta drill a little divot inside the shaft for that set screw to sit in to lock in tighter, because this is gonna have some torque put on it. So I really need that set screw not to slip. So I do have to drill a little, like a countersink hole on the shaft.
And drilled and tapped a hole for a set screw on both of the smaller plates. Can't see it in there. There's one on each side. So that I don't have to weld anything to the shaft. I can actually pull everything apart. Like I said, I'm going to put holes here
Yeah,
The
so
nuts on the backside.
I'm just trying to keep it serviceable so it can be disassembled and you can get to each part of the machine if anything happens. And it's just I was fascinated with the fact that I got it spinning at this point. I love that. I'm getting so close. Oh yeah, the bearings, they have this little lip on one side, but on the other side there's like a groove. And I figured if I get the right retaining ring, I would use that to mount it instead of welding the bearing to the plate. That way, if the bearing goes bad, I can just pop the retaining ring off, slip the bearing off, and buy it and replace. I'm trying to keep it serviceable.
Hard enough to get the retaining ring on there. That'll help hold this bearing in place so I don't have to weld it. Therefore, I can remove it and replace it when they go bad. Even if I had to take a grinder and gouge around the hole a little bit thinner so I can get that retaining clip on.
Which I did.
Whatever's clever. But that's coming in the mail right now. I can get my finger.
Yeah, I ordered the retaining rings. Unfortunately, I didn't quite measure. I should have used my calipers and measured it. I ordered the wrong size. But it was okay because I used like an end grinder and I ground out the inside of it open. I made it a little bit thinner, but it ground it open enough for me to get the ring to snap in. So in the future I'll have to order some the next size up, I believe. Like 2732 or something rather than 3/4 or something like that. I can't remember exactly. So this is just an idea of a cutout I want to put, like I was saying earlier. I want to cut some weight out and make the spokes on these to remove some of the material, take some weight down. And while I'm doing it, I might as well come up with an idea and make it fancy. I was thinking of something like that, or something like that. You know what I mean? Or like a biohazard symbol, just some kind of fancy cutout, which I haven't gotten to that point yet. This is just another one of seeing it run. This is the one where it's on the pipe stand, that's why it's moving so smoothly. I mean, that looks pretty smooth. Other than like any imperfection in the actual roundness of the pipe itself, I think it's actually dead center. There are little blemishes in the way that it was formed round. It's called bumping. If you run your hand around the pipe, you can actually feel a little bit of a wavering in the formation of that circle. So I think I see there. What did I get? I got 1 3/4. That's what I got. 1 3/4, and I think I need 1 2732. I think is the next size up. I think is what I should have tried. So I just ground out the inside open a little bit, especially more down the bottom where it's thicker. Okay, you see that? And yeah, I can actually zoom in for you too. Oh, I lost my place. Are you serious? Yeah, so I can zoom in. See how it's thicker on the bottom end, the opposite of those two little holes. So I ground into that and made it a little bit thinner to open it up a little bit, and was able to get it to snap in and work.
Bearing is here.
Oh yeah, that's when I finally got the second one, the back ordered bearing. Both bearings are in. Moment of truth. Is it centered?
Completely free spinning.
Looks pretty fucking good to me, dude.
Look at her go.
Everything's still loose fit in there. Nothing's anchored down, so it's wobbling a little bit and it's sliding as it goes, but it's centered. It's not hitting the damn cores. You know what I'm saying? That was a crucial factor, and I nailed it, dude. I think I got it right on. So yeah, there's that retaining ring that I told you. I said I had to grind around and thin the plate a little bit to expose more of the groove so I can get that in. I did that, and that worked out really good. And again, like I said, I had to grind out the ring itself to make it fit.
Out, and I've got the retaining rings on.
So that worked out really good. Again, in the future, I want to order some of the right size ones because I don't like the way it's in there. It's not all the way snug. Like it's still kind of sprung open a little bit, holding it in there. I don't know, but it's in and it's holding, so I don't have to worry about that too much. Repeat. There's the compressor I want to get. There's the new tester I just bought. Remember the other one I said blew up in my friggin' hand? This one goes up to 1,000 volts in certain configurations, so hopefully I don't blow this one up. Okay, these are one of the most recent things I have done. These rings I had to make for the inside, so it's the same size pipe. I had to trim an exact amount out of it and then close them back up so that they fit inside the other one. So I had to change the ID in the OD to the ID. I had to match the OD of the little one to the ID of the bigger one. So here it is. I got them cut. I got them squashed back together. I got them welded out. Did a little dry fit. It actually fit. And by the way, I got the measurement of how long of a piece to cut off of it by asking ChatGPT to do the math for me, and it was spot on. So another kudos to ChatGPT. I'm not for the whole AI revolution, but there are instances where that technology is very useful, and this was one of them, just helping me with my math so I can worry less about what I have to do and more about actually doing it, if that makes sense.
I didn't even have to weld it. I'm gonna, but I mean, I had to tap this in with a hammer.
Like slip ring tight, dude. ChatGPT was on the freaking money.
And then I can weld nuts on this, and that'll bring the hole away from this edge when I bolt these on.
Very important. I think this is when I got the other side done. I got that all cleaned up and fit in. Same. Tapped in with a hammer. It was snug. It was perfect, dude. Absolutely perfect fit.
They don't get any tighter than that.
They really don't. Anything tighter than that, and you'd have to, like, I don't know, heat up the fucking outside, expand it, and then slide this in and let it cool down, fit it in, because it was that tight. It was almost that, to the point where I'd have to have done something like that just to get it in. That's how tight it was. On to the small one. Same thing. It needs a ring to raise those mounting holes away from the edge of the plate. That's just another video of the same. There's the rings for the small one. See the cutout in the top? That's how much I had to cut out of them, and then squeeze them back together to make them fit the inside of that size pipe. And the thing is, especially I think with the smaller one, doing that made it an egg shape, and I had a fix for that. Yeah, it's just the 10-inch rings with the so much cut out and rebeveled. Here we go.
Forged in Fire has big glue.
See, it's an egg. My first job in the steel industry was making stainless steel pipe out of flat plate, and I worked with my father, and I would make the pipe, I would form it, and then he would run the seam welder that ran the seam, and when it came out, the whole banana was like a big smile from the heat from that seam. I had another machine with a piston that would do this, I would do it to the center and make it the pipe straight again, and then I'd do each end and measure all the way around, make sure it was the same measurement all the way around again, made it round again. That's what gave me the idea to do this. Like, oh, I could just squish it like I used to squish pipe. And I don't have a hydraulic press, but I do have an iron worker, baby. So I went too far. You just go back the other way a little bit. It's actually easier with the carbon than it was the stainless, because the stainless springs back a lot. Stainless has a wicked memory. You squish it and bring it back, and it comes back further than you expect. It doesn't adhere to that form as easily as the carbon steel does. It did right here.
Successfully made a 10-inch OD.
Yeah, a 10-inch OD pipe. That's an odd size, trust me. There's my big blue.
Use what you got. Be safe.
So that's my big blue. Then I just clean them up with a grinder, get them polished up, get the welds ground down flush, and make it fit. More of the same, I believe. Yeah, doing the polishing the top edge, getting rid of all the rough coating so that when I slide it in there, there wouldn't be any friction, any resistance. It was just the polished metal going on to basically polished metal. It made it fit easier, even though it was snug as a bug. So yeah, I polished them all up. That's how they looked. And then they tapped in with a hammer.
Ta-da!
That one was a little loose because it was still a little egged. It was tight on one side. I fixed it.
Pretty snug. I have to tap it in with a hammer.
That one was perfect.
So fuck yeah, I got both of them in. They're inside. Now I can weld them in. After I measure and get the right distance in, I can weld them in. And then I gotta buy a set of nice grade 8 or better nuts and bolts to weld on here. And then I gotta put the holes on the plates so I can press it up against these heat rings and screw a bolt through onto the nut that I weld on the inside. And that'll close everything up tight, and I can start putting the setting up the magnets in the magnet holders.
Oh, I'm so excited for that step. The magnets.
The magnets are in and everything's buttoned up. I can work on the gearing and the belt system to turn it and put the coils in.
I need the exact
Start testing it.
RPM, and I know the ratio I need to get there, so I just need to build it. I've already designed it, now I just need to build it. Oh, another shot of my new tester. Oh, yeah, me and a coworker were using it to help work on my bike, and we couldn't get a good reading on anything. We couldn't figure out why until the next day I realized the caps were still on the front. Sitting there trying to get a connection inside friggin' little tiny connector. So I sent him this as a joke. Like, no wonder we couldn't do it. Anyway.
Hey, I got something done on this thing.
Yeah, you can see the set screw coming out of the collar on the side there.
Nice.
And the sides are now in. They fit flush up against the ring. Welded.
Weld it in on both sides. See down there. Weld it in. Little by little. Making progress.
And as I said, I can't even lift the damn thing by hand. I need to use the crane to lift it off like the cart that I stash it on when I'm not working on it and put it on my work table. I gotta use a friggin' crane to lift it and move it around. So I think this is me putting the welds in to the ring for the big one. And this was just like not too long ago, a few days ago, last week or something like that. So we're getting close to the end of this little. I said it was going to be 2 hours, dude. I was right on the money. We are at 2 hours right now. So here it is. I'm welding this in. I had to clean up the inside afterwards from the spatter, because remember I polished the inside of that one. So I was kind of disgusted with all the spatter. I had to clean it up and polish it.
I'm going on my break.
Yeah. Like I said earlier, I'm just working on this little by little, like in between jobs. Like I finished up something and it was about break time. I went and threw a couple tacks in, got that fit up, and then went and took my break. You know what I mean? So I mean, just every chance I get to do a little bit more, That's why it's taking so long. But it's coming along. See, now I got it welded in. The big one now. This is the big one. The last video was just tacking it in. Now I actually took a day and actually ran some stitch welds, because I didn't want to run full passes, because I didn't want to start warping it. You know what I'm saying? I want to keep this round shape. I want it to be right, so I didn't want to overheat it too much. So I only stitch welded it in. And this is an order summary for the grade 8 bolts and nuts that I ordered on the 1st. Just, what, 3 days ago? What's today? The 4th? Yeah, 3 days ago I ordered those. Those right there. Yes, those. And Friday, they were here. So, like in the video, I mentioned having to weld the nuts on that ring, which brings the hole further away from the edge of those plates. So when I put the hole in the plate, it's not real thin to the end. I got a little bit of material. You know what I'm saying? So I had to recess or whatever the mounting holes by adding that inner ring. And that's just me bragging that they came and freaking out because it's Friday night, currently Saturday night, and I just want it to be Monday so I can go to work and start plotting on where the nuts fit in there, start trying to prepare to fit these up and get them welded in, so that then I can mark where the nuts are located on the plate, find the center, and punch the holes for the bolts to go through. And once I can bolt it together and, like I said, countersink that set screw on the shaft so it won't slip, then I'll be ready to put the magnets in. And once the magnets are in, I do need to create the pulley system for the motor to run it, but once they're in, I can actually just direct line the motor and spin it, and with the coils put back in, and start putting my tester on the terminals of the coils and see how much I get when I spin it and how fast if it'll even spin it, and if I can get it up to speed, which is why I'm not going to build the pulley system until I've got it spinning and I can test whether it will spin and how fast I can get it to spin, because if I can get it to go wide open, the impact gun I got was like 65,000 RPM, or it was something 6,500. I can't remember, but the math wise, it works out that in order to get it down to like the 1,200 RPM that I need to make 60 hertz, I need a what was it? A 5-to-1? Was it 5-to-1? No, I can't remember. I'll have to do the math again, or I have it written down somewhere. But it's like either a 5-to-1 or a 3-to-1. I think it's 5-to-1. 3-to-1's the other thing. I think it was a 5-to-1 ratio to make my RPMs the 1,200 I need to be putting out 60 hertz synchronized in phase waveform of AC power. But that is from where I began to where I'm at right now. That is as far as I've gotten, or that is how far I've gotten so far. And like I said, I'm so close to the testing stage now. I'm getting really excited. So, and people are noticing more of my posts and are asking me, "Hey, what the hell is this? What are you? What this is? You know?" So, because of all the interest, I figured I'd jump on here and explain to all my musical fans why I haven't been really saturated in the music like I used to be. Because I'm like I'm geared towards something else at the moment. I'm coming back to the music. I'm slowly trying to figure out what I want to do there, but this is why I haven't really been around much, and I haven't been on my channel because this isn't music. So I haven't been streaming or posting to my YouTube channel because it's not music. I've been posting it on Facebook, sharing with my friends and stuff, and a lot of it publicly. But I just thought I would come here and just lay it all out. This is what I've been up to. I mean, so to my followers, please don't unfollow. I mean, I hope you appreciate my music, but I hope you appreciate my ingenuity and my other endeavors as well, and stick around and be patient. There's more music coming, I promise. And I really got to get this out of my head. I've had it in my brain since since the 80s, 1980s. Okay? Since the 80s, I need to get it out. I need, once and for all, so I can just forget about it and start focus. Like, so much of there are so many windows open in here relating to this project alone that this life itself is barely compatible with my firmware at the moment. So bear with me. The music will come back, but please support me in my other endeavors. Give me a shout out, and thanks for watching. I nailed it, dude. I guesstimated about 2 hours of footage, and I actually nailed the 2-hour timeline. So I'm gonna say what I always say on my work videos: stay safe and work smarter, not harder. Peace out. That's full disclosure. I don't know how to end it, so I'm just gonna say goodbye, guys. Bye. I'm starving, and I was told food was here like about 2 hours ago. Peace.